2 days left. December 19th is exactly 2 days away, and JPL is rolling out the updated ephemeris as casually as if it were just another row of numbers in a long tape. But this time, the numbers don't behave like numbers. They behave like a gaze, as if something in the darkness has finally found something to look at and is now stubbornly maintaining its aim. Everyone's used to thinking of a comet's trajectory as a line, a beautiful arc on a diagram, smooth and inevitable. In reality, a trajectory isn't a line. It's a cloud. It's a field of uncertainty around the line, living in every correction, in every new photon, in every pixel we squeeze out of the noise. We call this covariance, and usually as more data is collected, the cloud shrinks. It settles down. The error decreases, and the probabilities gather into a neat blob around the true path. But 2 days before 3I/ATLAS's closest approach to Earth, the cloud didn't shrink. It stretched out. At first I thought it was a visual artifact, the wrong interface layer. The scale was wrong. JPL panels have a tricky pitfall. Switching between the uncertainty ellipsoid and the probability tube along an arc can create the effect of an object aiming somewhere, when in fact it's just the geometry of the graph. I was about to close the tab and avoid embarrassing myself in front of my colleagues, but then I saw that the extraction was strictly in one direction. Strictly towards the Earth, not approximately, not on average, not apparently. The covariance vector was so aligned with the line leading to our planet that it looked inappropriate for randomness, as if nature had suddenly decided to be overly careful, and nature doesn't do that. Nature loves noise, loves asymmetry, loves messy data. I opened the raw parameters, the p-matrix, the eigenvalues, and the eigenvectors. The longest axis of the uncertainty ellipsoid rotated and lay almost exactly along the geocentric direction at the moment of approach. The errors in the transverse components, on the contrary, were compressed. Rather than spreading, they were compressed. The result was a strange corridor. A narrow tube aimed at us like a telescope sight that's already calibrated but hasn't yet pulled the trigger. And then something happened that I don't even like as a joke. I caught myself thinking, it looks as if the object isn't just flying, but choosing how to be indefinite. Do you understand what's most frightening about the word covariance? It's honest. We don't just draw it on for show. It's a mathematical signature of how the system reacts to information. If the error cloud extends in a certain direction, it means one thing. The system is either less observable in that direction, or it's actually experiencing a disturbance in that direction that we can't yet accurately measure. And then I saw the second line in the JPL update. The one that almost no one looks at because it doesn't sound like a big deal. Non-gravitational parameters adjusted. This is the polite formulation that hides the entire hell of cometary dynamics. A real object in space never obeys pure gravity perfectly. Comets evaporate gases, eject dust, and experience microshocks. It's like a jet engine, only dirty, natural, and unpredictable. These non-gravitational effects usually make the orbit less predictable. They inflate the error cloud. They add chaos. But now JPL is saying the opposite. They've adjusted the non-gravitational parameters, and instead of chaos, we've got a corridor. Narrow, focused, almost perfectly aligned with Earth. Then everything started happening quickly, even though no one raised their voices outwardly. NASA's internal chats favor a dry tone. No one writes, "We're finished" there. They write, "Request review. Need confirmation. Please check residuals." And that's precisely why reading them is more terrifying than any scream. Because their panic doesn't start with words. Panic starts with the silence between the lines. At 3:17 UTC, the first request came in to compare the residuals with observations from the Martian segment. We have known for a long time that Atlas used Mars gravity slightly, but in textbooks, it looks like a smooth curve. In reality, any gravity assist maneuver is a seam that must be perfectly stitched between the models. And if the seam doesn't match, you see it in the residuals. The small differences between where the object should be and where it actually is. Usually, these remnants are random, give or take. Sensor noise, atmosphere, calibration. Here, they weren't random. They formed a pattern. And there was only one pattern, a tiny but consistent shift along that very corridor that now faced Earth. Possibly degassing, someone wrote. CO2/CO activity is changing. Then it should be visible in the photometry, they replied. But the photometry does not confirm sufficient emission. Then there is an error in the solar radiation pressure model. Solar pressure will not give such a directional correlation to Earth. Then instrumental taxonomy. Is the systematics the same at different observatories? With different cameras? With different atmospheres? Seriously? Every answer felt like a closed door, and every closed door left us on a corridor that increasingly resembled not a mistake, but a route. At this point, I must explain one thing, otherwise the point is lost. When orbital uncertainty turns into a corridor, this corridor can intersect so-called keyholes. gravitational gaps in space through which an object passing now will experience a completely different approach scenario in the future. It's a well-known story with asteroids. A small difference today can make a catastrophic difference years from now. But Atlas had no future in our system. It's on a hyperbola. It will fly away. It won't return in an ellipse. It won't orbit the sun in a way that makes sense for the keyhole. That's why the thought that came next resonated so loudly inside my head. The corridor isn't about the future. It's about the goal. I've only seen something like this once before, many years ago, when we were analyzing planetary probe navigation. When a spacecraft makes tiny trajectory corrections, the error matrix actually stretches in the direction where you allow uncertainty and contracts, in the direction where you control it. It looks like a system that maintains course but allows itself freedom along one axis, either because it's unimportant or because it's being used as a conduit. And now I looked at the comet, which is called a natural object, and I saw behavior that I was used to seeing in machines. At 11:40 UTC, JPL rolled out the second update package. On the public page, almost nothing had changed. A few numbers, a couple of lines, some neat brackets. But in the package's private appendix, there was a graph that would make even the most placid people stop joking. The graph was called neutrally. B-plane uncertainty projection. This is a way of looking at the approach through the meeting plane, as if you were throwing an object at a target and seeing where it would land, given the uncertainty. Typically, you see a beautiful ellipse on this plane. In our case, the ellipse turned into a long, narrow trace, tangential to the Earth as if someone had traced it with a ruler. It passed near the line where our most sensitive zones are located. The geostationary arc, some orbital resonances, the region where our satellite density is at its highest. Not because a comet could hit the satellites, that's too far. But because if any interaction mechanism exists, that's where we, as a technosphere, are most vulnerable. The highest concentration of satellites, the highest dependence on timing, the highest density of radio links, and the corridor, as luck would have it, ran right there. That same evening, a report arrived from the group analyzing radio emissions. I expected anything. Nothing unusual, noise, weak signal. But the report contained one word that makes people stop drinking coffee and start counting. Structured spectrum. ALMA, and several ground-based radio telescopes operating in other wavelengths detected a thin millimeter signature in the tail of Atlas. This in itself is not sensational. Comets do have molecular lines, but this structure was strange. It didn't resemble a pure molecular line. It looked like a line with a modulation superimposed on it. Weak, almost hidden, but stable enough to be extracted using correlation methods. And here's the most disturbing part. When this modulation was compared with the archive of terrestrial radio noise, coincidences emerged. Not similar frequencies, not roughly similar. What matched were fragments of modulation from old transmissions and signals that had long since left Earth for space. Bits of television signals, old radar patterns, fragments of commands to spacecraft, where the rhythm and code structures are unique. That is, the tail of Atlas, in the millimeter range, seemed to re-emit our own traces. The comet didn't just glow, it echoed. I saw someone in chat trying to be rational. It could be intermodulation, a processing side effect. But then another person, more angry and honest, wrote, if it's a side effect, why do the delays match the light time? And this was a blow to all attempts at calm. Because if the echo delay corresponds to the distance to the comet, then we're not hearing our own signal inside the lab. We're hearing it there, at the other end, and we hear it as if the object is receiving, processing, and returning. The night before December 18th, I barely slept. Not because I was afraid of a strike. There was no strike scenario, no flying dangerously close. There was something else, the feeling that we were standing next to a system that could use our own signals as a tool. And at dawn, the strangest thing happened. The new JPL ephemeris showed an even more elongated covariance, but now the corridor wasn't just pointing toward Earth, it was stabilized. Stabilized, meaning its orientation barely changed as new observations were added. We added data, and the corridor maintained its direction. This is the opposite of how an error behaves. An error should wander and gradually decrease. Here, it held its course. One of the young analysts, not at all inclined to drama, sent me a private message. It contained just 2 lines. If this isn't a bug, then this looks like a managed uncertainty on SAW. I don't know how that's possible. I didn't know either. But I knew that managed uncertainty is exactly what a system does when it wants to remain unpredictable where it benefits and predictable where it needs to be. On the morning of December 18th, a closed teleconference was held within NASA. Usually such meetings are routine. Who observed what, where the noise was, where the calibrations were. Here, the routine ended with the second slide. The slide was simple. 3 data sets, optical, radio, dynamics. and one common fact. All three showed a direction toward Earth in their statistical residuals. Optics. Tiny positional discrepancies, systematically shifting along the geocentric direction. Radio. Modulations correlated with terrestrial noise and transit time. Dynamics. Covariance. Stretched and stabilized into a corridor. One channel can explain randomness, the executive said. 2 channels. Hard. 3. Almost impossible. And then someone said something that no one likes to say in mainstream science. What if it's not us who are miscalculating, but the object actually does what makes us think that way? The classic response was, extraordinary claims require extraordinary evidence. But there's a problem with such phrases. They sound nice until you realize that the extraordinary is already in the data. You don't have to believe in a fantastical hypothesis to recognize that covariance isn't behaving as it should. From that point on, the conversation became cold and technical. They began listing possible mechanisms that could create the illusion of targeting Earth. Option 1, non-gravitational acceleration due to outgassing. Objection, then a corresponding change in brightness and spectrum should be visible, but this is not supported to the required degree. Option 2, solar radiation pressure and an unusual dust composition. Objection, this influence is directed away from the sun, not toward Earth, and does not produce a stable covariance orientation. Option 3, erroneous alignment of star catalogs and systematics in astrometry. Objection, different observatories, different catalogs, different algorithms, and yet the same direction. Option 4, an unknown gravitational factor in the trajectory region, such as a dense cloud, body, or resonance. Objection, then the manifestations would be symmetrical and not targeted at Earth. Each option died in the details, and in the end, what remained was a category that no one likes because it sounds like defeat. Unknown unknowns. But here the unknown unknowns look too disciplined. Late in the evening of December 18th, JPL released another update. This time, without further explanation. Simply a new trajectory, new parameters, a new corridor. And at that very moment, something happened that made even the most stubborn skeptics stop arguing for at least an hour. The corridor moves closer, not millions of kilometers, not dramatic magnitudes, hundreds of thousands, scales that seem nothing in space, but in orbital geometry. The difference between far and too precise. And here's the worst part. The shift was too precise. It looked like a correction after a maneuver, not like a random remarking, not like we found a mistake, but like a precise hit on the new line. If someone wanted to make us nervous, they would do it abruptly, loudly, with effect. This was different. Here there was a feeling that someone was working not for drama, but for results. That night, I looked again at the P-matrix, at its eigenvalues, at how it lived, from update to update. And one thought kept coming back to me. We're used to thinking of uncertainty as our weakness, something we don't know, something we diminish through observation. But what if uncertainty is someone's defense, someone's strategy, someone's behavior pattern? Then the covariance drawn strictly toward Earth isn't our mistake. It's their choice of how we'll make mistakes. And if this is true, the scariest thing about this story isn't even that Atlas is taking aim. The scariest thing is that it does it in a way that makes it look almost natural, almost believable, almost chalked up to comet effects. Because if you want to avoid being stopped, without panicking, without intervening, you don't take any obvious steps. You leave people the comfort of doubt. At 200 hours UTC on December 19th, the last packet of the night arrived. Final pre-encounter solution, the last solution before closest approach. I opened it and stared for a few seconds, as if my brain refused to process the geometry. The corridor was there, narrow, clear, targeted. And now it crossed the region we internally called the technical shadow, the area where our planet is most noisy, in radio, where the orbital infrastructure is densest, where time synchronization is critical, where even the slightest external factor can trigger a cascade of strange glitches. This still wasn't a threat of impact. This wasn't a movie-like end-of-the-world scenario. This was far worse psychologically, a situation in which an object might do nothing physically, but it could do something to our system because it was passing through where it was most strained. And right at that point, as I closed the file, a faint notification chime sounded in the room. One short ping from a colleague at DSN. He didn't write long messages. He never dramatized. His texts were always dry. This time, he sent only one phrase. We see a repeating echo of commands to distant spacecraft. It comes from a cone that coincides with the covariance corridor. And the delay changes as if the source were moving along a line to Earth. I read it 3 times, and only on the 3rd reading did I understand what struck me. The echo wasn't just coming from the Atlas area, it was coming from the corridor of uncertainty. That is, from the area where we mathematically say, we're not sure exactly where it is. From there, where the object, if it were a system, could hide part of its behavior under the guise of observational error. At this point, the idea of a targeting cloud ceased to be a metaphor. It became a working model. The object exists to be simultaneously observable and elusive, and its elusiveness is directed at us. December 19th was just hours away, and the scariest part wasn't that we were waiting for an event. The scariest part was that the event was already happening. It was happening in numbers, in correlations, in the subtle discipline of errors. And if there's something in space that can control how we make mistakes, it doesn't have to hit us with a rock. It just needs to pass by. It just needs to look. It just needs to tune our own noise so that it becomes a channel. When closest approach begins, people will see a green dot and say, "It's beautiful, but nothing happened." And we'll be looking at the corridor, which didn't disintegrate but held its course. And we'll ask ourselves the question no one likes to ask out loud. If it's just a comet, why does its uncertainty behave like navigation? And why, with 2 days left until December 19th, has everything that should have become clear become even more clearly directed at us? The phrase, echo of commands, is the kind of thing that shouldn't exist outside a lab accident. Our deep space transmissions are engineered to be one-way, clean, and ruthlessly directional. They are not supposed to come back as something coherent, timed, and shaped. I pulled the DSN logs and did what every tired scientist does when reality starts slipping. I tried to blame the pipeline, a deconvolution artifact, a correlation ghost, a bad clock. But the timestamps were anchored to 3 stations, 3 independent atomic references, and the pattern persisted through different calibration passes. The echo wasn't a mirror, it was a remix. Fragments of old command frames appeared inside the millimeter band structure, but with tiny phase shifts, as if the signal had been passed through an alien filter that preserved the skeleton and rewrote the muscle. Enough of it remained recognizable to trigger our pattern-matching alarms. Enough of it changed to make the alarms useless. At 6:12 UTC on December 18th, someone in JPL's internal chain sent a quiet memo that never reaches the public. Not a press statement, not a headline. A small procedural note: do not distribute high-resolution uncertainty visualizations outside the consortium until post-encounter review. That's the bureaucratic equivalent of closing the blinds. By mid-morning, the word corridor stopped being a metaphor. People started using it like a place. The corridor had coordinates, cross-sections, projected densities. It became an object of its own in our minds. A narrow tunnel of probability where Atlas could be, and where, inconveniently, the structured radio anomalies kept originating. We were no longer tracking a comet. We were tracking the shape of what we could not confirm. That afternoon, Alma's team pushed a fast-look reduction, the kind you do when you can't wait for perfect processing. The plot landed in my inbox like a cold coin. The millimeter emission from the tail wasn't just present. It had directionality that did not line up with the sun, did not line up with the classical anti-solar dust flow, and did not behave like a simple outgassing fan. It was biased toward the corridor. A narrow beam-like enhancement, faint but statistically stubborn, extended from the comet's radio tail into the exact region where our uncertainty tube pointed. If you overlaid the ephemeris corridor and the beam axis, the alignment looked less like physics and more like intent-wearing physics as a costume. I didn't say that out loud. Nobody did. We spoke in safer nouns. Anisotropy, unexpected collimation, non-thermal component, instrumental coupling to background. But our eyes kept doing the same thing. They kept tracing the beam forward to the place where the comet might be, and then further to the place where the comet should not be, and then all the way back to us. By evening, agencies went quiet in a way you can feel through the internet. You don't need an official blackout to sense it. The cadence changes. The routine updates stop. The public trackers become slow. The friendly outreach accounts pivot to old photos and harmless facts. It's not censorship, it's containment. And then the first real-world symptom arrived, small enough to be dismissed, precise enough to haunt. A cluster of low Earth orbit satellites reported brief, synchronized timing slips. Not a total outage, not a spectacular failure. Just a flicker in timekeeping. Nanoseconds stretched and snapped back, too fast for most systems to notice, but long enough for a handful of payloads to log unexplained phase discontinuity. People blame solar weather for that kind of thing. It's a comfortable scapegoat. But the sun was quiet. The slips followed a schedule that matched the repeating structure in the tail emission, as if the sky itself had developed a pulse and our hardware was feeling it in its bones. Late that night, I reran the orbit fit using a deliberately blind approach, stripping out anything that could bias toward the Earth direction. Different catalogs, different weighting, different assumptions about non-gravitational terms. I wanted the corridor to rotate away so I could sleep. It didn't. The corridor changed shape. Yes, it thickened here, narrowed there. But the long axis kept snapping back toward the same corridor in B-plane projection, like a compass needle that refuses to point anywhere else. The more I fought it, the more it felt like the math was telling me something simple and brutal. We are not the reference frame anymore. We are the target frame. At 1:03 UTC on December 19th, the DSN team sent another message, shorter than the last and far worse. The echo is no longer delayed like a reflection, it's advanced. Advanced means the structure appeared before the corresponding command frame was even transmitted in that specific form. Not by hours, by fractions of a second. The kind of offset you can explain with buffering, except the buffering was on 3 continents, through separate chains, with separate software. If the time ordering flips even slightly, you don't reach for exotic theories first. You reach for clocks. You audit everything that touches time. You suspect sabotage. You suspect errors so stupid they feel impossible. You do not, under any circumstance, assume the universe is bending, but the audits came back clean. Clean enough that the only remaining option was the one nobody wanted to write down. The signal wasn't coming back. It was being reconstructed, as if something out there had stored a library of our transmissions, learned the grammar, and could now generate credible, Earth-like echoes on demand. Not perfect, not identical, but close enough to trigger recognition and distorted enough to carry something else inside. A carrier wave hiding inside our own voice. At 3:40 a.m. UTC, the closest approach clock became the center of everything. 2 days left had turned into hours left, and suddenly every observation felt like it was happening in the same breath. Optical stations reported the green coma holding steady. Spectroscopy hinted at odd ratios, but nothing that would justify the radio behavior. The dynamics remained stubbornly hyperbolic, meaning it was not captured, not bound, not staying. And still the corridor aimed at us like a question. That's when one of the senior navigators said something quietly during a small call. Not a dramatic line, not a cinematic confession, just an engineer sentence that made the room colder. If it can shape our uncertainty, it can hide inside it. The idea is terrifying, because it's practical. If the object had any capacity to modulate how it appears to us, the best place to do it is the part of the sky we already label unknown. The corridor isn't just a statistical product, it's a permission slip. It's the region where our model accepts ignorance without breaking. Hide there and you can do things while we argue about residuals. At 600 UTC, Alma ran a follow-up pointing, chasing the beam-like component in the millimeter tail. The new reduction didn't just confirm it, it sharpened it. The radio tail looked less like a plume and more like a line, a thin, disciplined thread that refused to behave like dust, refused to behave like gas, and refused to align with solar forcing. It pointed into the corridor as if the corridor were not a mistake, but a coordinate. And then, on the edge of the noise floor, the line flickered into something that shouldn't exist in a comet tail at all. A repeating sequence of gaps. Not absorption lines, not frequency notches. Literal. Temporal. Gaps in the emission pattern occurring at prime number intervals 2, 3, 5, 7, 11. The kind of structure you would never expect from natural outgassing. The kind of structure you would use if you wanted any mathematician on Earth to stop breathing. Nobody wrote message in the report. They wrote non-random temporal structure consistent with discrete gating, because that's how professionals scream. We were hours from the moment the public would call closest approach, and yet everything important was already happening in the shadows, inside timing systems, inside uncertainty geometry, inside the quiet behavior of a tail that wasn't acting like a tail. I looked at the corridor one more time and realized the worst part. It wasn't widening as we approached. It wasn't losing control in the final hours. It was tightening, like a noose that only becomes visible when it's already around your throat. And the only question left was the one we had been avoiding since 2 days left became now. When Atlas passes the point of maximum proximity, what exactly is it passing close to? The Earth's body, which it will miss by astronomical margins, or the Earth's systems, which it has already learned to touch without leaving fingerprints? If you want, I'll continue straight into the closest approach window itself. The first minutes when the timing slips spread, the moment the corridor collapses into a single corridor line, and what the radio tail does when it finally crosses the line of sight geometry it's been preparing for. At 10:18 UTC, the public tracker still spoke in calm numbers, as if distance alone was the whole story. Behind the scenes, we stopped talking about kilometers and started talking about geometry, line of sight, phase angle, the thin slice of sky where the corridor and Earth briefly overlapped. The closest approach was never a single moment. It was a window where the math became brittle. In that window, a tiny change in assumed acceleration could swing the predicted path across millions of kilometers. That brittleness was the first thing Atlas seemed to understand. Right before the window opened, the corridor did something I have never seen in a fit this mature. It didn't broaden with uncertainty like a tired model should. It's narrowed, not smoothly either, in steps, as if a hand was tightening a knot one tug at a time. The step pattern matched the gaps Alma had flagged in the radio tail. Prime intervals again. The kind of coincidence you can't swallow twice, because the second time it stops being a coincidence and becomes a signature. At 10:41, UTC DSN ran a routine uplink bundle. Harmless maintenance, a nothing command set, the kind that gets sent and forgotten. The moment the carrier is locked, the millimeter feed lit up with a clean spike on the same cadence, as if the comet was waiting for us to speak first. It didn't reflect the command. It responded with an echo that started before the uplink finished. A predictive echo, shaped like our own packet framing, but with edges that were too sharp, too deliberate, too uncomet-like. Then the echo changed format midstream. The same bits, the same structure, but rearranged into something that looked like a map. Not an image, not a literal diagram, a mapping function. If you treat time as one axis and frequency as another, the output drew a curve. When we overlaid that curve against the corridor collapse timeline, the match was so close that the room went silent in the way labs only go silent when someone has just realized they can't unsee the pattern. Outside, nothing exploded. No bright flash, no cinematic sky event. That was the second lesson. The scariest phenomena do not announce themselves in the atmosphere. They announce themselves in the infrastructure that quietly keeps civilization stitched together. By 11:06 UTC, the first civilian symptom surfaced through unrelated channels. A handful of aviation ADS-B receivers reported brief position jitter. A few shipping systems logged micro discrepancies. People blame software updates and cheap antennas because blaming the sky is never anyone's first instinct. Inside the agencies, the language changed. The phrase timing slip got upgraded to time integrity event. The word localized has disappeared. The slips weren't global, they were directional, strongest on the night side, facing the corridor. At 11:21 UTC, the corridor collapsed again, but this time it collapsed wrong. It didn't converge toward the nominal ephemeris. It converged toward a point slightly offset from the expected track, like the solution was being pulled toward something adjacent. That offset sat exactly where the radio tails beam pointed, not towards the nucleus, not towards the coma, toward empty space that our model had been treated as a statistical blur. The corridor wasn't tightening around Atlas, it was tightening around the place Atlas was indicating. And then, JWST's internal status page blinked, briefly visible to a small group before access got locked down. A single line, GuideStar acquisition anomaly, another line, instrument safe mode pending review. Nothing dramatic, just a normal failure message with an abnormal heartbeat, because at the same minute JWST tried to sample the corridor region, its detectors returned something that looked like perfect black, not dark, not low signal, perfect black with the background noise floor missing like someone had cut it out with scissors. Space is never perfectly black to a real instrument. There is always dust glow, a zodiacal light, thermal noise, readout noise, cosmic background. Perfect black is a physical insult. It's what you get when the system is seeing absence, not darkness. The corridor tightened once more. Then for the first time since this began, it did the opposite of what fear expects. It opened, but only in one direction, like a door swinging on a hinge to reveal a narrow corridor behind the corridor. Alma's beam followed that opening as if it had been waiting for permission. The radio tails line sharpened and then fractured into two parallel threads, close enough to look like a single line until you zoomed in. Two threads, two lanes, a bifurcation with the same spacing that our tracking residuals had been whispering about for days. The three observatory, three positions problem suddenly felt less like measurement error and more like a clue we had refused to interpret. At 12:03 UTC, the closest approach window hit its peak geometry. Atlas was as near as it was going to get, still astronomically far, still harmless by impact standards, but the corridor, the beam, the timing, all of it aligned in a way that felt engineered, and that's when the echo stopped being an echo. The downlink systems registered a signal that used our modulation, our framing cadence, and our error correction rhythm, but it did not originate from any human transmitter. It was coming from the corridor region itself, as if a transmitter had been switched on in the exact patch of sky we could not directly resolve. The content was not a message in words, it was a handshake, a negotiation between protocols. It probed our receivers the way our receivers probe the sky, testing thresholds, adapting to filters, shifting just enough to stay inside the windows we allow. If you've ever watched two computers negotiate encryption, you know the feeling. Fast, silent, procedural. A conversation without language, where intent is expressed through constraints. The handshake ended with a sequence that matched frighteningly well an old DSN internal diagnostic tone, a tone that never goes into open space, a tone that lives inside our ground systems, like a private knock on a door. Someone out there had learned our knock. At 12:19 UTC, the last thing I saw before the comms rooms went into full containment mode was a fresh orbit solution overlay. The corridor did not point at Earth anymore. It pointed through Earth, past it, toward a line in space that made no astronomical sense for a comet, a line that intersected the positions of several lost interstellar candidates if you propagate their inbound vectors backward. a line that suggested the visitors weren't random and Atlas wasn't first. It was a marker being read as a checkpoint, and then the simplest, most chilling operational note appeared in the chat, written by someone who is trying very hard not to write anything at all. Closest approach complete. Approach. Phenomena not complete. If you want me to continue, the next segment is the aftermath hour by hour. What the corridor does when the geometry breaks, why the radio tail keeps pointing after the flyby is over, and what NASA quietly changes in the public ephemeris language to hide a brand new variable they can't name. The hour after closest approach was supposed to be the cooling off period, the part where you exhale, publish a calm plot, and let the world go back to sleep. Instead, the data behaved like it had been waiting for the geometry to break. When the line of sight angle shifted, the radio tail should have drifted, smeared, and weakened. It did the opposite. It remained locked like a pointer refusing to follow the comet and insisting on following something else. At 12:44 UTC, the ALMA team reran the pointing with a small offset, not because they expected anything, but because the beam alignment was becoming a problem you couldn't ignore. The beam followed the offset. Not slowly, instantly, as if the center of emission was not a cloud, but a coordinate. That's when the corridor split, not in a poetic sense, in a statistical sense. The covariance ellipsoid, which should remain unimodal unless you have garbage data, developed a second peak. Two solutions with nearly identical residuals, separated by a distance too large to be explained by noise. The two-peak solution lasted 14 minutes. Then it collapsed back to 1. 14 minutes is not an orbital timescale. 14 minutes is a decision timescale. At 13:02 UTC, DSN quietly stopped uplinking everything non-essential. Not because of fear of contact, but because the act of transmitting had become a stimulus. Every time we spoke, the sky answered in our syntax. A senior comms engineer called it feedback coupling. It was the safest way to describe a situation where the universe was acting like a system that had discovered our control knobs and started turning them back. By 13:18 UTC, the timing slips migrated. They were no longer strongest on the night side. They were strongest along a strip of longitude that moved with Earth's rotation, tracking the corridor's projected path like a spotlight sweeping a stage. Civilian systems started to log it, but only as annoying anomalies. Navigation jitter, timing retreats, brief authentication failures that self-corrected, the kind of glitches that happen every day, until they happen with structure. At 13:41 UTC, a small, ugly pattern appeared in the satellite telemetry. Systems that used independent timing references behaved better than systems that relied heavily on GPS disciplined clocks. That detail shouldn't matter unless the disturbance was touching time distribution itself. The phrase clock contamination appeared in a draft memo and then vanished from the next revision. Someone replaced it with signal integrity irregularities, which is what you write when you don't want your own engineers to panic. At 14:05 UTC, a request went out to compare Atlas's emission structure against archived terrestrial radio content. Not just broad matches, but deep fingerprints. The kind of matching you do when you suspect you are being imitated with intent. The first hits were embarrassing in how mundane they were. Fragments of old weather broadcasts, a few seconds of a long-forgotten talk show, the handshake tones of legacy satellites. Not the content that matters to humans, but the content that matters to machines. And then one match made the room go quiet for a different reason. It wasn't a broadcast. It was a probe command acknowledgement sequence, a very old one. A pattern used decades ago by a spacecraft that is still out there, still alive, still answering in a language built when computers were simpler and trust was assumed. Someone asked, calmly, how would a comet know that? Nobody answered with words. We answered by opening more archives, because the only way to survive this kind of day is to keep working until the fear has no air. At 14:32 UTC, JPL pushed a public ephemeris update that looked routine to everyone outside. Same tables, same language confidence, same gentle disclaimers. Inside the fit, one new parameter had been introduced. It wasn't named thrust. It wasn't named a non-gravitational acceleration. It was named like a nuisance term, something you add when you want the model to stop screaming. Phase-dependent residual correction. That phrase is a confession. It means the errors weren't random. They depend on geometry, on alignment, on phase angle, on when Earth and the corridor lined up in a way that made the anomalies stronger. At 15:07 UTC, JWST's team circulated a minimal internal note. The detectors didn't fail. The guide stars didn't vanish. The telescope didn't go blind. It saw a region where the expected background statistics collapsed. Not dim, not noisy. Collapsed. If you've ever lived in signal processing, you know what that implies. Either your instrument is broken, or the input is being shaped to look broken. And JWST's instrument diagnostics looked fine. At 1529 UTC, ALMA's beam thread did something no one wanted to see. It began to precess, slowly, steadily, like a lighthouse turning, except it wasn't turning around the nucleus. It was turning around the corridor line. When the precession rate was fitted, it matched a simple ratio with Earth's rotation frequency. Like the system was referencing our planet not as a destination, but as a metronome. At 1611 UTC, a private network of astronomers shared a dirty trick. Replot the radio tail's time-frequency structure as if it were a spectrogram of speech. You shouldn't do that. You'll see faces in clouds. You'll hear voices in static. But we did it anyway, because we were running out of rational explanations and the data kept offering structure. What emerged wasn't a voice. It was punctuation, bursts, pauses, repeats, the same cadence you see in protocols that negotiate, retry, and confirm. A machine rhythm, impatient and precise. At 1647 UTC, one of the Keck operators reported a brief moment where the object's astrometric solution jumped by an amount that would normally trigger a software error. It didn't trigger an error, it triggered a correction. The pipeline accepted the jump as if it had been expected. That's when the paranoid thought sounding stopped paranoid. If the pipelines were being quietly trained to accept certain deviations, then the real battle wasn't happening in the sky. It was happening in our interpretation of the sky. At 1722 UTC, the corridor reappeared but shifted. Not by much, enough to change who was looking at it and when. Enough to place the strongest projected disturbance over different ground stations on the rotation next. It felt like the system was learning our schedule, then moving to stay in our blind spots. At 1804 UTC, a DSN tech sent a message that never reached any official channel. It was the kind of thing you whisper to someone you trust because you don't want it on record. The private tone came back again, but this time it came back with a checksum we haven't used in years. Checksums are not astronomy. Checksums are intent. It meant the thing out there wasn't just replaying our patterns. It was updating them. It was tracking our changes, our revisions, our quiet evolutions and how we talk to the void. At 1836 UTC, the corridor stopped being a corridor and became a point. A tight, almost insulting point in the sky where uncertainty should still have room to breathe. The point sat just off the comet's projected track like a shadow walking beside it. The radio tail's beam pinned it perfectly. JWST's perfect black region overlapped it like a mask. 3 independent systems, 3 different wavelengths, 1 shared absence. At 1910 UTC, the first serious internal hypothesis was finally written down in a form that could be debated. Not alien, not craft, not technology. A softer word, more dangerous because it's less dramatic. Proxy. The idea was that 3I/ATLAS itself might be natural, but it was carrying a behavior, a coupling, a mechanism that turns our own emissions, our own tracking, our own observation campaigns into an input signal, a proxy that only wakes up when we look hard enough. If you want to understand why that's horrifying, here it is in plain terms. A threat that approaches you can be tracked. A threat that hides can be hunted. A threat that activates only when observed turns your curiosity into a trigger. And in the hours after closest approach, it became clear that the comet wasn't leaving. It was moving on, yes, hyperbolic, outbound, departing forever by every classical metric. But the phenomena did not depart with it. The corridor point remained. The black region remained. The private tones kept knocking at our receivers like someone testing whether the door was still there. At 1942 UTC, ALMA's precession rate shifted again, as if the system had completed a phase and moved to the next. The beam stopped drawing toward the corridor and started writing around it, outlining a shape you could only see if you were willing to connect dots. A loop, not a closed circle, a loop with a gap, like an unfinished symbol waiting for one final stroke. Someone in a room I wasn't in must have asked the obvious question. What completes it? Because at 2013 UTC, as Earth rotated and the right instruments came into alignment again, the loop's gap narrowed, and for the first time since this began, a new line appeared in the data. A second radio tail, fainter, offset by a fixed angle, pointing not into the corridor, but away from it, toward the opposite side of the sun, toward the place a mirror orbit would hide. If you want me to continue, the next segment is the mirror hour. The first measurable anomaly in the sun-shadowed sector, the moment we realize the 2 radio tails are not tails at all, and the reason the corridor point refuses to be resolved even when we throw every wavelength at it.